Chapter of dispersion, we have already discussed the two methods of the dispersion. The very first we have discussed what is the range method and how to calculate the range is over there. Secondly, in another video we have discussed what is quartile deviation, how to calculate the quartile deviation, whether in the series is discrete or individual or continuous series is over there. Today we are going to discuss another one methods of the dispersion, that is called mean deviation. Mean deviation can be calculated with arithmetic mean, median and mode. We are having, we can calculate from all these three items of center tendency, we can calculate mean deviation. So the very first we should know what is the mean deviation. Mean deviation is the arithmetic mean of the deviation taken from the mean, mode and median. So what we are saying, mean deviation is the arithmetic mean of the sum of the deviation taken from either mean or median or mode. It means we are firstly we are taking the deviation from either in arithmetic mean or median or mode. We will ignore plus minus sign from the deviation, and then sum of that deviation and arithmetic mean of the sum of that deviation will be called the mean deviation. Let me see, suppose we are to calculate, this is the symbol, sigma is the symbol of mean deviation. Suppose I am to calculate mean deviation from arithmetic mean, then I have to use sigma dx divided by n. So what I am saying, mean deviation is the arithmetic mean of the addition of deviation taken from arithmetic mean, that is called mean deviation. We have taken the deviation from arithmetic mean, ignoring plus and minus item, we will add all the items and getting the arithmetic mean, that will be mean deviation. So the mean deviation can be calculated with arithmetic mean also, with median also, or with mode also. So in today's video we will learn how to calculate in a case of individual series or discrete series, how we can calculate mean deviation. Suppose we are taking mean deviation from median, so we have used sigma del m divided by n. If we are taking from mode, then sigma del z divided by n. Here this symbol shows ignoring plus and minus symbol. So the very first, to calculate the mean deviation, the very first we will calculate mean, then we will calculate the deviation from mean, ignoring plus and minus, then sigma dx, it means the deviation taken, we will add all the deviations value and then get the arithmetic mean of this, then we will get the mean deviation from the arithmetic mean. Similarly, the very first we will calculate the median values over there, and then we will calculate deviation from mean. Taking the deviation from mean, we will add all the deviation and taking the arithmetic mean of this, we will say this will be the mean deviation from the median is over there. Similarly, the very first we will calculate model value, then we will calculate the deviation from model value, ignoring plus and minus item, then we will add all the deviation, then arithmetic mean of that deviation will be called the mean deviation from the mode. So the mean deviation is a single item which can be calculated from median, mode and arithmetic mean. Now the second one, this mean deviation, these formula are this formula of mean deviation are the we are having absolute measurement of the dispersion. To calculate the relative measurement of dispersion, we will having the coefficient of mean deviation, that is mean deviation divided by arithmetic mean, coefficient of mean deviation from median, that is arithmetic mean deviation divided by median, and coefficient of del z, that is mean deviation from mode divided by mode. So these are the relative measures of mean deviation, and these are the absolute measurement of the mean deviation. The absolute measurement of the deviation have some unit, but the relative measurement of the deviation are not having any unit. If we want to change, if we want to compare between both two or more series, then we will change these into percentage. So we will 100 multiply by 100 to get the proper comparison of the mean deviation, in which the deviation is high or in which deviation is low. So to get this, so the very first we should know how to calculate the mean deviation. So in a case of individual series where the absence of frequency is over there, we will use these formula to calculate mean deviation. Mean deviation from arithmetic mean, that is delta deviation from arithmetic mean divided by arithmetic mean. If we are to calculate the deviation from mean deviation from median, then sigma deviation taken from the median divided by the divided by n. It means we are having the arithmetic mean. Suppose these items are from these formula are used to calculate the mean deviation for the discrete series over there. But in case of the individual series, for a case of individual series, we will use these formula to calculate mean deviation. But if discrete or continuous series over there where the frequencies lies, then we will change these formula. In small change will be over there. So this formula for the individual series. If discrete series और कंटिन्यूस सीरीज हो रहे देन डेल्टा एक्स बराबर सिग्मा एफ डेल्टा एक्स बार डिवाइडेड बाय सिग्मा एफ, डेल्टा एम बराबर सिग्मा एफ गुना डेविएशन टेकन फ्रॉम मीडियन डिवाइडेड बाय सिग्मा एफ, डेल्टा जेड मीन डेविएशन फ्रॉम मोड सिग्मा एफ गुना डेविएशन टेकन फ्रॉम मोड डिवाइडेड बाय सिग्मा एफ. It means if we are having a case of discrete series or continuous series where the frequency lies, so we will use f here, and here n is equal to sigma f. So we are using n sigma f at the place of n. So the formula for the mean deviation will be having sigma frequency multiply the deviation taken from the arithmetic mean divided by sigma frequency. If you are want to calculate the mean deviation from median, then the formula will be sigma frequency multiplied by the deviation taken from the median, ignoring plus and minus item, divided by the addition divided by sum of the frequency. If we want to calculate the mean deviation from the model value, so the formula will be sigma frequency multiply by the deviation taken from the mode divided by sigma f, and coefficient of mean deviation, the formula will be the same for the mean deviation taken by x bar, coefficient of mean deviation from median, that is mean deviation from median divided by median, coefficient of mean deviation taken from the mode, then delta z divided by z. So this, with the help of this, we can calculate very easily how to mean deviation we can calculate. In this video, we will calculate for a case of individual series how we can calculate the mean deviation. We will learn with the help of a question. So I think this version is sufficient to calculate the mean deviation. Here we have to now, where the two parallel line is over there, it means it's a symbol of ignoring plus and minus item. So how to calculate the mean deviation? I am giving an example to calculate the mean deviation that will be very beneficial to learn how these formula will be used to calculate mean deviation. So, the latest we are having one or two example to calculate the mean deviation. Okay. So, the very first, if someone asks you what is the definition of mean deviation, so very first you have to give the definition of the mean deviation, that is mean deviation is the arithmetic mean of deviation taken from either arithmetic mean, either mode or either median value, that is called the mean deviation. It's a very important methods to measuring the dispersion. Sometimes in examination also we are taking a questions from the mean deviation. So if you are having a question from the mean deviation, how you have to solve that question, let us learn this also. Suppose we are having a case of individual series, a case of individual series. If individual series over there where the frequency value is not attendant, so in a case of individual series we can calculate arithmetic mean, we can calculate model median value, but we can't calculate model value in the case of individual series. So for a case of individual series we will calculate mean deviation from arithmetic mean and median only, but in case of discrete series we will calculate mean deviation from arithmetic mean, mode and median. All three items we will use to calculate mean deviation. So the firstly I am taking an example of an individual series. Example is over there. Suppose we have given x value 47, then 50, then 58, then 45, then 53, then 59, then 47, then 60, then 49. Suppose these items, 9 items are given to calculate mean deviation. We have to calculate mean deviation from arithmetic mean or median. For calculating from the arithmetic mean, the very first we have to calculate the arithmetic mean of the data. For calculating mean deviation from the median, the very first we have to calculate the median value of the data. So firstly what I am doing, this is serial number 1, 2, 3, 4, 5, 6, 7, 8, 9. Firstly I am arranging these data in ascending or descending order to calculate the median value. Median value, as we know, median value is that value which divide a series into two equal parts. One part contains value less than median and the second part contains value more than median. So the very first we have to calculate the median value. To calculate the median value, firstly we have to arrange the series either in ascending order or either in descending order. So I am arranging this series into ascending order. So ascending order, the very small item is 45, then 47, then 2 times 47, then 49 is over there, then 50 is over there, then 53 is over there, 53 is over there, then 58 is over there, then 59 is over there, and last one is 60. So the very first what we have done, we have ordered in all the series in ascending order. Then median is size of n plus 1 upon 2th item value. So size of, we want some place to take the deviation from median, no problem, we can calculate. Then size of 9 plus 1 upon 2th item value, that is 10 upon 2th item, that is 5th item. So the median value is 50. What the very first we are calculating the median value. So for calculating the median value, we are using the formula size of n plus 1 upon 2th item is value, because this is a discrete series, this is an individual series, and in individual series we use that formula, that is n plus 1 divided by 2. Okay, so the median value is 50. So dm, that is x minus m, we are to calculate deviation from taken from the median. So we will subtract 15 from all the items. 45 minus 50, 45 minus 50, that is 5, plus minus ignoring. So we will ignore plus and minus. So the very first item, 50 is the median, so the median value is 50. Okay, so 45 minus 50, that is 5, ignoring plus minus, we are not having any essence, because these symbols show that we have to ignore plus minus. 47 minus that will be 3, 47 minus 50, 3, 49 minus 50, the 1, 50 minus 50, 0, 53 minus 50, 58, 9 and 10. What we have done here, we can learn 45 minus 50, that is 5, plus minus ignoring. 47 minus 50, that is 3, plus minus ignoring. 47 minus 50, that is plus 3. 49 minus 50, that is plus 1, ignoring plus minus. 50 minus 50, that is 0. 53 minus 50, that is also 3. 58 minus 50, that is 8. 59 minus 50, that is 9, this dm. So the very first we will add all this item, that is 5 plus 3 plus 3 plus 1 plus 3 plus 8 plus 9 plus 10, that is 42. So the mean deviation is sigma x minus m divided by n. So x minus m, ignoring plus minus, we will not care about the plus minus value, all item will be treated as a plus value. So the mean deviation is 42 divided by 9. So the value of mean deviation will be 42 divided by 9, that is 4.67. Coefficient of mean deviation, that is mean deviation divided by median, that is 4.67 divided by value of median, that is 50. So the 0.0933, 0.0933 in percentage form, so mean deviation divided by median multiplied by 100, 4.67 divided by 50 multiplied by 100, that is 9.33%. So it's very easy to calculate mean deviation. Mean deviation 0.934, we can write here 4, no problem at all. This mean deviation we have taken from the median values. The very first we calculated the median value, then we have taken the deviation from the median value, ignoring plus and minus, then adding all the items, that is called sigma x minus m. This value is 42. So we are putting in formula sigma x minus median divided by n, that is 42 divided by 9, that is 4.67. Then coefficient of mean deviation is equal to mean deviation divided by median, that 4.67 divided by the median value is 50, already we have calculated. So the coefficient of mean deviation is 0.0933, and to having the comparison between the two series, we will change this mean deviation into the percentage form. For the percentage form, that will be mean deviation divided by median multiplied by the 100. So we are having 9.33%. So we have calculated the mean deviation from here from median. Now we will calculate the mean deviation from arithmetic mean. The very first I am writing mean deviation, coefficient of mean deviation, that is 0.0933. This answer. Now we are to calculate mean deviation from arithmetic mean. So the very first we have to calculate the arithmetic mean for that. So arithmetic mean is equal to sigma x divided by n. So the very first we will add all the items to get sigma x. So we are adding 45 plus 47 plus 47 plus 49 plus 50 plus 53 plus 58 plus 59 plus 60. So the addition is 468. So getting arithmetic mean, that is 468 divided by, the very first we have calculated, the 468 divided by 9. So we will divide from 9, so we will get arithmetic mean, that is 52. So here the arithmetic mean value is 52. Now we will take the deviation from the arithmetic mean. So this will be ignoring plus and minus x bar. It means we subtract 52 from each of the items. It means 42. The very first we will divide 42. 55 minus 52, that is 7. Ignoring minus 7, but ignoring plus minus 7 is over there. 47 minus 52, that may be having minus 5, but ignoring, that is plus 5. 49 minus 52, that is minus 3, but ignoring 3. 50 minus 52, that may be minus 2, but we are not having anxious about this. Now 53 minus 53 minus 52, that is plus 1. 58 minus 52, that is plus 6, plus 7 and 8. So this is the value of deviation taken from the arithmetic mean. Now we want addition of this sigma x minus x bar. So we will add all these item, that is 7 plus 5 plus 5 plus 3 plus 2 plus 1 plus 6 plus 7 plus 8, that is 44. So addition is 44. Then mean deviation taken from arithmetic mean, that is sigma x minus x bar divided by n, that is 44 divided by 9. So the very first value of arithmetic mean deviation, that is 4.89. That is 4.89. Now coefficient of mean deviation, that is mean deviation divided by arithmetic mean, that is 4.89 divided by 52, because x bar is equal to 52. So 4.89 divided by 52, that is 0.0940. 0.0940 in percentage form. The mean deviation divided by x bar multiplied by 100, that is 4.89 divided by 52 multiplied by 100, that is 9.40. So we have taken two mean deviation. We have taken mean deviation from the median, that is 9.33, 0.933. Coefficient of x bar, that is 0.0940, or percentage 9.33% or 9.40%. So we can say that we are having more value of mean deviation from the arithmetic mean than the median. So for the comparison, it may be having some difficulty in comparison, but we are changing in percentage form. There is very easy to we can say that the value of mean deviation are more from the arithmetic mean than median, it means the in second series we can say. So this is the methods to calculate the mean deviation for a case of individual series is over there. If your series are discrete series, then we have to change some formula to calculate the mean deviation. So a case of discrete series over there, we will discuss that also in the same video. In a case of discrete series, how we can calculate the mean deviation, now we are discussing here. In a case of discrete series, in discrete series we may be having the value of x bar, we are having two value, x value and f value. So a case of discrete series, I think we will having another one separate video to calculate the mean deviation in discrete series, that will be the beneficial for that. So I think this video is helpful to learn how to calculate mean deviation in a case of individual series. Thank you.